All right, let's take a look at topic 2, which is all about surface area of pyramids, cylinders, spheres, and cones. So using some of the stuff we talked about last time, let's calculate the surface area of the pyramid. So what we're going to do, or what our plan is to break this apart into its smaller two-dimensional shapes and come up with a formula that we can use for every pyramid. So what we can do is surface area. Now that pyramid is made up of a square. If you notice, the bottom length and width are both 40 meters. So if they are the same, I am indeed working with a square. So I have to deal with one square, and I have to add to it 4 triangles, and those triangles are going to come from my pyramid. Now I know those triangles are going to be the same because the dimensions on my square base are going to be the same. So all of those triangles have the same base, and that base has a dimension of 40 meters. So I am going to add 4 triangles. All right, so my square, we're going to take care of using our length and width. And our triangles, we're going to take care of using base times height divided by 2. So let's go and put some dimensions in here. For my square, that's going to be 40 meters multiplied by 40 meters. And I'm going to have to add to it 4 multiplied by the base times the height, so 40 meters multiplied with 25 meters, and that product needs to be divided by 2. Now that's all set up. Surface area is equal to 40 multiplied by 40 will give us 1,600
please call 2313, please.
meters squared, and we're going to add to that 2,000 meters squared, and in total the surface area of our pyramid is 3,600 meters squared. Okay, so again, just breaking that composite 3D shape into its two-dimensional parts. Okay, so as we did the surface area of that pyramid, we're going to continue to look at different three-dimensional objects and calculate their surface areas as well. Okay, so how do we calculate the surface area of all prisms and pyramids? We calculate the area of all the sides then add them together. Okay, next let's look at a cylinder. So the cylinder is going to have 2 circles on the top, and oddly enough, it has a rectangle in the center. So let's draw out what this looks like and start putting some dimensions on here. So here's my rectangle. Let's try that again. I can cheat a little bit with the iPad and it draws me a straight line, but my left hand usually gets in the way. All right, that's a little bit better. Now, we're going to have 2 circles, so as best you can, draw 2 circles on there, roughly the same size. Now, the circle is easy to deal with. We know it has a radius, so we're going to add that into our picture, and we're going to call it R. Okay, both circles are going to be identical. They're both going to have the radius being the same. They're both going to be R. Now the top part of that rectangle, just above that circle, we're going to call the height. Okay, it's how tall our cylinder is going to be. The other dimension on that rectangle is going to be a little trickier to comprehend. Now that's going to be the circumference of our circle, okay, or the perimeter of our circle. And that is denoted by 2 pi r. Okay, the other way that you could represent that is pi multiplied by the diameter, where the diameter is the two radii combined. But since we're given the radius in our picture, we're going to use the form that has radius in the circumference. Okay, so circumference of a circle can be given as circumference is equal to pi multiplied by the diameter, or circumference is equal to 2 multiplied by pi multiplied by the radius. And this is the form we're going to use. Okay, so in order to come up with a surface area formula for my cylinder, I need to remember what the area of a circle is. Okay, and the area of a circle is pi r squared, but since I have two circles, I'm going to have to double that. So surface area is going to be equal to 2 multiplied by pi multiplied by the radius squared, or r times r. Okay, I'm going to have to add to it the area of my rectangle, just like we did for the other shapes. All right, so my rectangle area is going to be length times width, but we've defined the length and the width to be two different things. Okay, so on the one hand, I have 2 pi r, and I need to multiply it by the height, which is denoted by h. Okay, so 2 pi r times h. And that will give me my surface area formula for my cylinder. And that will work for any cylinder. Okay, we'll look at some examples down below. Okay, surface area formulas could also be developed for spheres and cones. They're a little bit more complicated to work with, so those formulas are going to be given to you. So your sphere is represented by 4 pi r squared, and your cone is represented by pi times the radius times the slant height, which is denoted by s. And you're going to have to add to it the area of the circular base, which is pi r squared. Okay, so those formulas will be provided for you. Let's take a look at some examples. Determine the surface area of the following objects and round all answers to the nearest tenth if necessary. So for part A, I am given a cylinder with a diameter of 10 and a height of 9. Now our surface area formula, let's add it in here. I'm sure I have enough room. Yeah, we'll do it underneath. So surface area is equal to 2 pi r squared plus 2 pi r h. And we can start substituting in our dimensions. 2 is constant. Pi doesn't change. My radius this time, it needs to be 5 centimeters since my diameter is 10. My radius means I cut that diameter in half. So 5 centimeters squared plus 2 pi times the radius, which is 5. And the height of this cylinder is 9 centimeters. Okay, all of the dimensions have been put into our formula. We can go ahead, grab our calculators, and evaluate. So when I do all of that, I should get as my final answer 439.8 centimeters squared. And it is rounded to the nearest tenth. So here we go. There's our final answer. Part B, let's look at a sphere. Okay, my surface area formula for that sphere, use blue. Surface area is equal to 4 pi r squared. So the only dimension I need this time is the radius. Conveniently enough, it has been provided to me. So we can go ahead and substitute 4 pi, 12.5 inches squared, and my surface area of my cube is going, or my sphere I should say, is going to be 1963.5 inches squared. All right, part C, let's look at a cone. Okay, so I do have the slant height as 29. I have the height of the cone as 2.2. And I have the radius as 19. My formula for my surface area of a cone surface area is equal to pi rs. Now this is sometimes called the lateral area. Basically, it is, if you want to think about it, it's this, if you want to think about it like an ice cream cone, that would be the area of the outside of your cone. Okay, and we have to add to that the area of the circle that's on top, and that's going to be pi r squared. So let's go ahead and start filling in some numbers. Pi can stay there. I need a radius, which is going to be 19 millimeters. The slant height is going to be 29 millimeters plus pi. Radius squared. Okay, so as you can see, I didn't actually need the height of the cone itself. It is, however, provided to me. Sometimes we might not get it, and I might have to use the Pythagorean theorem to find out what the hypotenuse of that right angle triangle is. This time, no need to worry about it. We can go ahead, grab our calculators, and plug in some numbers, and we end up with 2865.1 millimeters squared as a final answer. All right.